Welcome to the Churchill Club. Our program tonight is called The Future of Human-Computer Interaction. How will we connect? We are privileged to welcome three distinguished speakers. We have, starting with Andy, down on the end, Wilson of Microsoft, Bill Mark of SRI, and Walt Johnson of PARC, who are here to contribute their personal responses to the question, the topic at hand, looking forward to around 2020, what's possible, where they see the biggest opportunities for innovation, etc. And here to lead them in conversation is James Temple of the San Francisco Chronicle. Welcome all of you, and thank you so much for being here with us tonight. We really do appreciate that. And thank you also to our partner and our sponsor, SRI. We really appreciate the opportunity to be here with you as well, and also your guidance and support in tooling the program. A brief introduction to Churchill Club for those perhaps less familiar. We are Silicon Valley's premier technology and business-related forum, an independent forum. We have been presenting Silicon Valley conversations since 1985, right around the time when Windows 1.0 hit the scene. And what drives us every day is to encourage innovation, economic growth, and societal benefit. And we do this through the up to 40 programs or so that we present, where like minds, such as the people in this room, can connect with one another and with ideas. Coming up next month, on September 26th, we present two of our greatest events of the year. First, a day-long conference about change called Changing the Game. The theme this year is power. We observe that there are new constructs of power, particularly in our own region here, that are emergent all around us, and that it is a rare moment of history that we're living in, with some of these new constructs of power enabled by technology. Some are enabled by new attitudes around things like leadership and collaboration. So we're dedicating a day to explore that theme. That same evening, we present The Churchills, which is an event to inspire you by highlighting excellence in leadership, collaboration, societal benefit, and innovation. So we hope that you will join us for those two wonderful events. If you're tweeting tonight, please do use the hashtag Churchill Club, and you will find other Twitter codes in your printed programs. Our moderator, James Temple, writes the commentary column for the San Francisco Chronicle. He blogs at sfgate.com, focusing on a range of tech-related topics, from public policy to privacy and security, robotics, artificial intelligence, and clean energy and climate change. James has won a number of awards for his excellent work from the California Newspaper Publishers Association, the National Association of Real Estate Editors, and other organizations too. Our topic tonight is of particular interest to him, and we look forward to the conversation that he will guide for us. So please do give him your warmest Churchill Club welcome.
Thanks very much. Thanks for coming tonight. Really appreciate it. I think it's fair to say that we've come a long way in human-computer interaction, and the only evidence I need is that when my father started his first job out of college as a computer programmer, he was programming on punch cards. Since then, we've had the command line interface, the graphical user interface, the mouse, touchscreen, voice recognition, motion sensors, and more. Being here tonight is particularly appropriate since at least two of the things I just mentioned were invented at SRI. But we've also got a long way to go, and so today we've got three researchers working to redefine our relationship, the relationship between humans and machines. And I'd like to start by asking each of them to just briefly introduce themselves and then talk about the way that the work that they're working on today in their labs are pointing toward the future, and specifically to touch on the topic mentioned in the flyers, how we'll be interacting with machines in 2020. So why don't we go ahead and start with you, Andy?
Yeah, thanks. I had the privilege of working on some very interesting work at Microsoft Research with some of the very earliest multi-touch tabletops that used cameras, video cameras, and my work is primarily based on exploring new sensing modalities to create new ways of relating to your computer. So we did the very first Surface table, affectionately known as the big ass table by some of you. And so it was a lot of fun to play around with that and some of the very earliest interactions around multi-touch and also tangible computing. And then quickly thereafter, I had also got really lucky to get some of the newest depth cameras that were just starting to hit the research market, so to speak. And so did a lot of the really earliest prototyping at Microsoft using depth cameras and thinking around what we can do with that in particular a gaming context. And the thing that really has captured my imagination about both of those interfaces and that style of interaction, just how immediate and fluid and seamless and magical they are, and also how the multi-touch stuff bears a real resemblance to the new spatial user interfaces that we're doing with Kinect. And in fact, in my own work, we used a lot of the very same software that we invented for Surface in some of the very earliest depth camera prototyping. And so the thing that really keeps me coming back to this is not only the sort of nitty-gritty and the fun part of working with signal processing algorithms, but just the amazing kind of connection that one gets by manipulating something with your hands and seeing that immediate and analog interaction take place. And that analog, I think, is the key word there, the idea that we can take the nuance of human motion and actually transform that into something interesting and useful so that you really feel like you're a part of the experience. And I think that the rise of multi-touch computing and touchscreens is a testament to that. And so now the question is, what is next? What is the next big thing? So anyway, that's where my mind is right now.
Great. Bill?
Bill Mark. I'm here at SRI. I get to run the Information and Computing Sciences Division. That's 250 researchers, 4 laboratories, artificial intelligence, speech, vision, and computer science, which is computer security and things like that. So quite a broad scope. My own background is in artificial intelligence, and I've been doing that for a long time. When I think about how human-computer interaction is going to be changing over the next 10 years, 7 years, I guess, according to the program, I think of 3 big things that are going on. One that's around us all the time is the rise of spoken interaction. So Siri, which actually came from one of my labs, is very famous, and everybody's gotten used to the idea of talking to a computer in some form. We're just at the very beginning stages of that, and as we go into the future, we're going to be seeing a lot more of that, deeper conversations, better speech, all of that. The other thing that is becoming very apparent is the importance of anticipation. So as soon as I say that, everybody in the audience thinks Google Now, and that's absolutely a good thing to think about, but it goes way beyond that. So not just thinking of computer-human interaction as talking to a computer, but also thinking of it as the computer anticipating what we need in any given context and giving us the information that we want. The third thing I'm going to guess is the least intuitive. So one of the things that's been talked about in computer science and the computer world for a long time is ubiquitous computing. And we were talking earlier about Mark Weiser, who's sort of the founder and the father of that. And we all agreed that it's amazing the extent to which his vision has come true. So we deal with computers constantly. We don't think about it. The brake pedal in your car, everything else in your car, everything around you is computerized. But the point I wanted to make is that when we talk about ubiquitous computing, we suddenly introduce the idea of space. And I don't mean the stuff up there. I mean space like we're in right now. And when we talk about space, we can talk about multiple people sharing a computerized space. And practically all of the human-computer interface work that goes on now is one person dealing with a computer. I think that will change dramatically. And I think it will be not all about, but a lot about multiple people interacting in a space where the computer mediates their interaction.
Great. Walt?
I'm Walt Johnson. I am I run the Intelligent Systems Laboratory at PARC, and my first job out of grad school was with the Intelligent Systems Laboratory at PARC. And several years later, I spun out and did the random walk through the valley of startups and stealth corporate projects and incubators and so on. And ironically, I was doing consulting at SRI when PARC called me back up a few years ago and said, "Would you like to come back to your old lab?" So I returned. One big difference is when I left, PARC was a captive research center, and we're owned by and worked for Xerox. So we spent a lot of time going, how do I make this be about copiers? Now we can do whatever we'd like, and we're about 2/3 non-Xerox work. The Intelligent Systems Laboratory, I think an interesting view on the change over time. At one time, it held our human-computer interaction group and our natural language group. We no longer have a human-computer interaction group, and we no longer have a natural language group. And I don't think it's because we don't care about those issues. It's just, as Bill was saying, ubiquitous computing had so many things fade into the background that we are much more concerned now about the usability of information. So when I got into the field, we were just transitioning, I think, from the human factors, Fitts law, the SRI mouse, and all the studies of that. We went through a cognitive inflection where it was, how can we take advantage of what people know to make better interfaces? And now all of that is, the intelligence is everywhere. Everything is connected. Everything has intelligence. And for us, I guess I have, and I have to be careful not to talk about some topics, but
Let's break some news. It's okay.
okay. The fact that with the ubiquity of information, people tend to lose track of the fact that they are constantly interacting with systems that are tracking them and keep recording what they're doing. And I loved Bill's comment about the brake pedal, because after he told me that yesterday, I went back and went, oh, yes, I am interacting with the computer, but I'm also interacting with Progressive Insurance Company. And I'm going to have higher insurance rates because of that human-computer interaction. And so with usable information, what we've been doing is looking at how is it that we can understand what situations are, and rather than come up with an artifact, understand what information people need to make the proper decision at the right time. One example is with nurses. We started a large program to look at how could we use AI in hospitals to make better decisions for nurses. We found out nurses are really smart. They make good decisions if they know what's going on. The problem was how do we get the information to the practitioner at the right time, in the right format, not down the hall on a screen. And once you solve that problem, you've solved their pressing problem, even though it's not quite defined as an HCI problem.
Great. Andy, when we were having a pre-discussion in preparation for this, you had mentioned the idea that improvements in computer-human interaction are going to get us eventually to this point where it's almost like humans will have some, what you called superpowers. So I want to know, when am I going to be able to leap over a tall building in a single bound?
Well, in 2020 is not very long from now, so we're not going to see that. But we were talking about, so I run the natural interaction group at Microsoft Research, and we get really hung up sometimes about what is natural. And what are we really doing with these so-called natural user interfaces? And clearly, there's a desire to simulate natural interaction as we see it in the real face-to-face interactions with people. And then the question there is, well, why do you really want that? What you really want is supernatural interaction, right? Because if you really want just to emulate face-to-face interaction, why not just have face-to-face interaction, right? One of the beautiful things about computing is the ability to manipulate thousands or millions of documents and just treat things as if they have no weight to affect action at a distance and these kinds of things. And so one thing that we've been thinking about is, well, so we can be a little bit flexible about what we mean by natural. Like, so, you know, when Michael Jordan does his layup or whatever, he makes basketball look natural, right? And so that's because he's Michael Jordan, whereas I could never do that. And so for me, it's very unnatural. And then, you know, another example would be actually just typing on a QWERTY keyboard is quite natural for many of us. And, you know, my 5-year-old daughter is getting, you know, the hang of it already. So, so the question now is, you know, if you want, we need to have some sort of notion of a target. Do we want to emulate natural interaction, or do we want to go for supernatural interactions, or what are the kinds of powers that we want to imbue our systems and our people? I don't think we're going to be jumping over tall buildings, but, you know, a good example would be telepresence, and I think that's something that's quite within reach. We've already seen some really interesting examples from you know, various companies, and that's one that we can work on and get. I think we can get really nice results there by 2020.
What about?
So it's teleportation. That's pretty close.
I'll take that. What about superhuman intelligence? I mean, things like we already have glass. Once we get glass as a contact, and, you know, we always have, you know, infinite knowledge at our disposal. Is that something that's on the drawing board, the sort of thing that we're going to start to see in the years ahead? The tools really, and shrunken down sensors that can, I don't know, be in our brain and that kind of thing.
So having information at your fingertips, and I mean, then the challenge is how do you wade through it all? We were talking about this earlier. Like, how do you present that? How do you don't want to be constantly bombarded with this kind of information in your eyepiece. And that is definitely an HCI problem. And so we've done some initial work on that and trying to mate the information that's available to the context sensing. So if we know where you are and what you're doing and what you've said, and these kinds of things have much better user modeling. Those are kinds of things that, yeah, of course, people are doing that sort of stuff. Right today, it seems like it's more in the context of web applications, but I see no reason why we couldn't, bring that out into the spatial interactions, the face-to-face, or as you move through your world, be able to use those same kinds of techniques. Sure.
I have to say, I visited the Stanford Virtual Reality Lab last week, and they put me in an immersive big city environment and then said, by the way, you can fly. And I could. And I would have paid $1,000 instantly for it. It's amazing what that modality does. But I think I have a larger concern, and that's the wading through the amount of information and the amount of ads that will probably be along with those bits of information. We've started to look at what we call the digital self, and in the short term, it might just make transparent to all of you when you're interacting explicitly with computer systems or non-explicitly, what have you told them and what do you know about them? Because right now I would bet there's no one in here who can raise their hand and say, I know everything that is known about me out there. And you probably can't get it back in any event now. But if you could just initially have something that traced what was going out that you could access. Now, we'd like to move that on to an avatar type system that actually could start to take over a lot of these interactions so that you can focus on the narrow, interesting interactions. But that's what a lot of what our group is looking at is.
So I would respectfully submit that you can't possibly know everything that computers know about you. Even if the information were shared with you. So just one example, kind of somewhat along the lines of what Andy was talking about, and gets at this question of how information is presented. We've been working on the system that we call Bright, and the idea of it is, it starts with a very simple idea, which is inspired by the way current computers work. So it was noticed decades ago that central processing units were sitting around doing nothing, waiting for other things to happen. So people started doing branch prediction, which most of the people in this room understand quite well. The system is using its extra cycles to predict the future of the computation. And then depending on what happens, it can jump from A to V. It doesn't have to go A, B, C. Okay, so take that idea and apply it to the human-computer interface. So here's a system that you stand or sit in front of. It has a lot of the gizmos that Andy was talking about. It has the cameras looking at you and things like that. And it's noticing where you're gazing, how long you're dwelling on it, which direction your head is pointed, all that kind of thing. And it's constantly collecting that information. That's why I think no human being could understand that. Well, what's it doing with all that information? It is helping it's helping your interaction. It's putting the things that you need right in front of you. But more interestingly, it's helping you interact with groups. Because I said before, I think interacting with groups is going to be a big deal going into the future. So just, for example, imagine the system knows not only whether you opened an email from one of your teammates, but how long you looked at it, and in fact, which lines of it you read. So if one of your teammates is assuming or not assuming that you've read that email, it can act differently for you. So I think that that's the future of that's part of the future of human-computer interaction that we'll see.
I absolutely agree that we can't ever know everything that's known. I guess I'm taking the be careful of Big Brother. And one of the things is just the cameras that are up everywhere that you will never know that are even taking your picture.
Sure.
In the fast track lane, you know, they're looking inside your car, and it won't be too long before they're recognizing who you are. It's a nice problem to worry about.
Bill, you've mentioned a couple times now this idea of anticipation and systems that are going to get better at not just responding to specific requests on our part, but starting to generate the information we need. And you mentioned Google Now as an example, and I've played with that and written about it a bit, and I think it's a very promising and interesting tool.
Right.
I feel like to some degree it's rudimentary so far. I almost have to program specific things into it to trigger it to act, just so I can see that it does it properly. But in 2020 and beyond, where do we get with that kind of thing? And what are going to be the sort of the technical advances that will push that forward?
Well, so I think that this bright thing I'm talking about is in that line. I think Google Now is a rudimentary start at it. I think the Google people would say that as well. So what's it going to be like, and what's going to make the change? I think that the anticipation will get a lot better. Okay, and partly it's exactly what Walt doesn't want, and that is the systems will know a lot more about you. And that will enable them to do much better anticipation. So one of the problems with Google Now is that the kind of information that it knows about you is limited. And even within that limited set, they limit further what they're actually going to make conclusions on. So it's pretty narrow. As that broadens, the system's going to be able to make better conclusions. Okay. The other thing, though, that we think about is if you think about human-human interaction, people, especially people that you know well and that know you well, are great at anticipating what you want, what you're going to say, and so forth. So I see some speech researchers here in the room. They know very well that neither humans nor computers really get the entire signal and understand everything in it. What's really important is anticipation. So if you take that as the point of departure, then it connects back to this idea of conversation. So imagine having a conversation with something or someone that knows you very well. It's anticipating what you're going to say, so it understands you better to begin with, and it kind of knows where you're going. So it steers the conversation in a way that's going to be useful. So I think all of those things are happening because the sensors are getting more ubiquitous, our ability to process the information is getting better, and our ability to understand the natural language and other natural interactions getting better.
Yeah, let me take my evil hat off and say I totally agree. And we have a number of user modeling projects going on because it's absolutely critical to have better and better models using more and more of the data if you're going to do what you want to do as well. So, for example, with all the sensors, we're kind of at a stage right now where we can aggregate all the data about you that we want, and it's the patches that will be available in a few years are going to be even more astounding. But to actually change your health, we can't treat you as just a human cog. We have to really understand, how do you learn, what do you do, what's an effective intervention, what are effective social groups that help you change your behavior. And all of those things require deep knowledge of you and your social group to be effective. And so my kind of inflection point there is, using it for good. It's essential for the future of interaction.
One thing I would love to see is if I'm having a good time, don't bother me.
Yeah.
Right? Or if I'm having a deep conversation with a colleague, don't interrupt me with some silly notification. And so people like to talk about this state of being in a flow state. And I think that one thing that would be lovely is if you're really grooving on a project and you're really working hard, rearrange my environment so that it's even a deeper kind of engagement, right? So I think that's a good, nice application. It's something that we could do in the near term. Mm-hmm. It touches on some of the things that we're doing in effective computing. You can look at GSR and these kinds of things. Get a bit of an eye tracking again is another great thing. You can use where you click on the screen and what kinds of things you're interacting with as kind of a proxy for eye tracking. If you don't have good eye tracking technology, but just having just enough knowledge of what kind of a level of engagement your user is experiencing, I think would be lovely. The systems don't even have that today.
Same goes for humans. So if you guys could work on a tool that would let my colleagues know when I'm in the groove,
sure.
Which doesn't happen very often, obviously. So I need to protect that rare time.
I just have to stick in here that's extremely relevant because some people are better at that than others. But if you go into this future world where humans are interacting with each other in a computational space, then it becomes even more important that the computational environment doesn't interrupt the flow. Because it's not just me thinking about a project anymore. I'm right in the middle of a conversation. What are you doing interrupting me? Right? So actually, I think, as Andy was indicating, I think that's a very tractable thing to work on. I think it's embarrassing for the field that we haven't done better already, because we actually have the information to do better.
Over dinner, the consensus seemed to be that we've actually reached, to some degree, this ubiquitous computing world imagined in that 1992 Scientific American article. But as I do the coverage I'm doing in the Valley these days, it seems to me like we've only scratched the surfaces in terms of what's coming between wearable computing, sensors in our home, the Internet of Things. So how does how did those trends start to, accelerate that shift, and how does that recreate kind of the world that we're all interacting in?
Well, so I can start. So the world is already, sorry, I have to be very careful. The world here for affluent people in Silicon Valley is amazingly computational already. I mean, the cars that most of the people here drove in are highly computational. So there's my brake pedal example. You've all seen the television commercial, I'm sure, where the car stops and because a little girl has put the ball in the street. That's a great human-computer interaction. It's good for the girl. It's good for the driver. It's good for everybody, right? So I just think I think both things are true. I think the world is highly computational, and it's going to get much more so. So what does that mean for human-computer interaction? There's a range, which we've talked about. So there's kind of the invisible. So for most people, their interaction with their brake pedal is invisible. Okay? They don't think about it. All they do is what they always used to do, which is hit the brake pedal. The computer then does something. And there's lots of examples of that in the world. Then there's the explicit, right? Like talking to Siri or typing at something. Then there's this whole range in between, which is where there's some really interesting stuff, where you're conscious that you're in a computational environment, but your interaction with it is implicit. So it's not invisible, but it's implicit. So if I'm in a meeting, one example and I'll stop. If I'm in a meeting that there's some computational capability listening to what's going on in the meeting, and we've worked in this area and done some experiments, then I can leverage that after the meeting to get a meeting summary, or somebody who wasn't at the meeting can get a meeting summary, or during the meeting, the computational system can show me things that are relevant, can pull things off the web or from my intranet and show me things that are relevant. That's an implicit interaction.
Does anyone want to add anything to that point?
Yeah,
I guess
go
go ahead.
I was just going to say it's really interesting to me, and I'm thinking back to Mark Weiser's original vision that at least where I work, we all have whiteboards in our offices still, and I find it curious that we've devoted all this effort and time to develop these amazing computational systems, and yet the one piece of technology that we tend to use when we're having a small meeting is the whiteboard. And we still haven't solved that one. So that part of Mark's vision is not done. And so one thing we've been trying to work on is just making these wall systems like the perceptive pixel displays. Microsoft acquired them recently, and just making the interaction on those devices as fluid and as simple to pick up and drop as a whiteboard. And it's hard because you want to give the user some ability to, it's very tempting to add this, that, and the other feature to this thing, and pretty soon you have drop-down menus, and then you have to log in, and then and what I'm finding with these systems is that if you can't be engaged within seconds, people aren't going to use it. I mean, the most you can do on a slate in your lap is type a pin in, and if it's any more than that, you're not going to use it for a quick note, right? And so so we have this real challenge of really just getting some of that functionality back without destroying it, adding some interesting capabilities. So that part of the vision isn't there. We're focused also on adding the sensing capability, like the cameras, and positioning information so that if I walk into your office and we know each other, I can immediately get something up on your screen and do that. And I've just arbitrarily set the bar at 3 seconds. Not sure if that's the right number, but so that you can have this kind of seamless kind of interaction. And this is the kind of thing that's really frustrating to me because in the research community we've been showing these kinds of demos for many years, and we still don't have it.
Yeah.
And so as a researcher, I look at it and it's wow, God, when do what's the problem here? And clearly there's a business challenge of getting people to agree on standards and this sort of thing. And that's certainly not the kind of problem I like to think about. But anyway, so...
having gone from actually using giant screens in the 80s to seeing up near your neck of the woods, the use of visual technology and Connects to rapidly turn anything into any whiteboard into a display, but a cool whiteboard, and since it's connected, it can be 3D as well. I have a feeling where we will take off before too long on that particular problem, that 25 years is long enough to talk about it, and we'll make some progress.
I hope you're right.
I wanted to say the other thing about your meetings is as we can start to model you more complexly and monitor your emails, V-mails, and so on. And we're getting better at emotional content, finding out those things from whatever modality. You'd like to have the flow retained because you can do it, and there are some things that you are willing to let a digital assistant actually do for you, not under your control. I'm very leery of a digital assistant not realizing that, no, I would never talk to that person or whatever, but I think we need to move to where computers can autonomously take actions for you.
The umbrella term that gets applied to a lot of what we're talking about here are natural user interfaces. And I'm curious if, I mean, we've talked a lot about what's possible here and what's becoming technically feasible. I'm curious, what's the goal? What's the broad goal? I mean, the natural user interface suggests that it's to interact with computers in a more natural, i.e. more human-like way. Is that a good way of capturing what we're trying to get at, or is there a broader, bigger goal here?
Well, I think the goal is to enhance human life. I don't care about how we interact with computers.
Okay.
So the point is, if the computational world makes something better for us, and some of these car examples that I was kind of kidding about truly do, right? I mean, if automotive safety is a huge issue, and if computation can help us, that's great. Walt brought up healthcare. That's another one where computation is going to make an enormous difference. So I have huge faith in that. Then the question is how to actually get people to use this stuff in a comfortable way. And that's where the so-called natural, and I think Andy brought up the point of what do we mean by natural, but putting people in a computational environment that's comfortable, pleasurable, fun, useful, that's what we're trying to do.
A question that you can tell where I am in my life right now. I chauffeur children a lot. And so I look at Google cars and go, boy, would I love to say piano lesson and not have to worry about them. Sure. But what it does make me wonder is humans aren't very good at a lot of things. I have car insurance for a reason. And what will the Google driver's license exam be? Will it have to be better than Bill's score? When will we actually...
Google has car insurance too.
They have more than I do. But, you know, when we're making these human versus, you know, intelligent system trade-offs, how much better do they have to be than us before we allow them to slide into our lives?
Well, I mean, again, if you think back, this argument went on over automated brake pedals, right? So I remember reading decades ago, there are certain circumstances, like when the road is wet or bumpy or something like that, when human braking is actually better, and it happens 0.001% of the time. And I actually don't think it's true anymore. I think the computer systems have gotten better. But that argument comes up all the time. You were just saying that you're skeptical about computer assistance. So am I, but I'm also skeptical about human assistance, right? So the question is, how well does our environment understand us? How well do we know how much it understands us, which is another good HCI problem.
We had a good example of truth imitating fiction last week. Elon Musk had a tweet. We figured out how to design rocket parts just with hand movements through the air. Seriously. We need a high frame rate holographic generator. This sparked a response from Jon Favreau because, of course, this is precisely what was in Iron Man. But it got me curious, where are we in terms of holographs, and where are we going, and how does that fit into everything that we're talking about here? Andy, I know you work to some degree in this area. Can you talk a little bit about what your thoughts on that?
Well, it is. So I saw some of the very earliest holo video systems back at MIT when I was a graduate student, and you know, when I saw the demo there, that was very simple, and it was clear that it was more a problem of just bandwidth right? Rendering is tons and tons of images, tons and tons of views, and getting those pixels moved around a desktop computer was really hard, impossible. And so they built all these kinds of special architectures to support that kind of computation. And when I saw that, I was thinking, wow, I hope to see one of these things become viable before I die. And now I'm much more optimistic. There are people doing all sorts of things with holo video systems, and so I'm dying to know what these guys have up their sleeve. We'll see. But there are people who are working on holographic video systems, and I think that by 2020 we should actually see some interesting visions of holography. Now, the way science fiction portrays these systems is very tricky, right? We're not going to see free space holograms like you see in Iron Man or even Star Wars with Princess Leia.
You're breaking my heart here.
Yeah, and my holography friends are they hate that little segment in Star Wars because they know that they'll never see that. So that you're still going to see a display, a frame. And the other, you often also see this portrayed in print, in magazines or whatever, where the stuff actually comes out beyond the bezel, right? And that always breaks my heart when I see that, because you're not going to see that either, for the same reason. But there will be some interesting things, I believe, in holographic video. So there are some companies who are showing things, and it's a matter of just cramming as many GPUs and the right optics. It's less of a problem in optics and more in terms of just rendering and bandwidth. So. Yeah, we also have another project where we've looked at different ways to specify shapes using a depth camera. So if I say, like, if I go up to, a store catalog and I say I want the chair that looks like this, right? We can specify, we can get that, and we can do a match on that. Go to a database of 3D models and make a volumetric representation from your hand gestures, and then match that to a database. That's something we actually had fun with a couple years ago.
That's a good segue into the market opportunities here. We've talked again a lot about the technical stuff and what's possible. What's the market pool? What are going to be the killer apps? What's going to drive this venture capitalists to invest in this and companies to bring these sorts of things to market? Bill, do you have thoughts on that?
Sure. I think it depends on what you mean by these sorts of things.
Yeah, there's a few. Yeah.
So clearly, again, if I go back to my three things, if we look at the rise of conversation as a way of dealing with the computer, there's huge venture capital interest in that right now. People come to SRI all the time saying we want do Siri for us in this domain, and venture capitalists come to us. So that's clearly here. That's on the rise. Mm-hmm. If we look at the sort of the anticipation thing, again, there's enormous interest in the venture capital community. There's lots of money floating around. My concern there, it's not a concern, it's part of the ecosystem. A lot of that is directed towards, roughly speaking, advertising, of getting messages in front of people. And I think there's so much more there in healthcare and things like that, where there's some, this is just my perception, there's some venture capital interest. I think there's more to come. And then finally I'll add something we haven't talked about but is somewhat related to the holography point, is augmented reality. So Google Glass is kind of popularizing that, but that field's been around for a long time too. And now, because of advances in computation and algorithm design, I think is right here now. So we do work in that area for training. There's a good example. So, mechanics of various kinds have, most garages work on the principle that any car that crosses their driveway, they're going to fix, right? And there's this voluminous old information about how to fix the car. Wouldn't it be great if the mechanics could put on glasses and they would know what to do and get some instruction? Wouldn't it be great for training? And I think we're starting to see commercial interest in that.
Cool.
I'll give an oddball example that gets beyond the virtual, but we're doing a lot of work in smart manufacturing based on DARPA work we've been doing for a long time. And initially from the automated vehicle make program, I think. But what it's really allowing us to do is take any 3D CAD design and drop it on a box and have it come back instantly and say, this is or is not manufacturable. If it is manufacturable, here are all the different supply chains that could manufacture it. Here's how much each step would cost, how much time it would take, who could do it. And by the way, this is the expensive part. And that means you're modeling your entire supply chain and all your tools. But it starts to put information at the fingertips of the designer about, is this a good design? Is it sustainable? Can it be done? And you're drastically cutting it down. And you're also democratizing who can do a design, because it's not just a little 3D printer. You know, this is serious metal work in addition to that. And if you want to, you know, design, there's 300,000 small manufacturers that don't use technology out there. That there's large untapped markets for.
So I'll add that our take on augmented reality, at least in my group, is to use projection technology with depth cameras so that we can, you know, everybody's probably seen the, you know, cool YouTube videos of projection mapping technology on buildings and this kind of stuff. We're doing that inside the room and then making all that happen in real time using the depth cameras. So one example that we had this past year was the IllumiRoom concept piece, where we had you're playing a game on a regular TV, and then the graphics actually bleed out selectively from the TV, and to do that in a way that where you actually correct the projection given the surface geometry of the things in your room, so that it really feels like you're in a real virtual space, or not. I mean, this is the kind of thing you can flout as a designer, and so our take is a little bit different. Rather than having something that you wear, we're pushing the pixels into the environment and then enveloping the user with imagery. And so it really draws heavily on some of the early cave work that was done many years ago now, and except we're using basically reducing the system to a box that you put in the ceiling. What I would love is a little thing that you set down. It's about like this, and then it basically transforms every surface in your room into an input and output space. That's a concept called the I/O bulb. That was something that again was coined at MIT, and I would love to have that as a device. I think that would be brilliant. And so you don't have to. I don't think we have to be necessarily wearing glasses. I think we can think of other kinds of things. If you're entering into a high infrastructure environment with where you could actually afford to mount something, that's kind of an expensive proposition, right? Mounting things in the ceiling. Why not use that ability to actually, and it also works very nicely, by the way, with multiple simultaneous users, because I can see exactly the same thing you see, and I see that, right? And I know that, so that's an interesting property of these systems. So we're playing around with multi-user versions of IllumiRoom and actually much bigger systems that involve multiple cameras, multiple projectors, and a little bit less of the TV aspect of it.
Yeah, and if you haven't seen it, you should look it up. And because he works for Microsoft, you should look it up in Bing. One of the other things I wanted to ask about, over the weekend I did a story about an annoyingly young guy down in Stanford. He's 18, from Germany, who's working on a Google Glass app that does essentially emotion recognition. And he thinks there's lots of training uses for this, but one of the things he's doing, or one of the things they want to test, he has a cousin who has autism, and he's wondering if there's the possibility of using that tool to help people with autism in similar disorders, help them along in terms of recognizing human emotion in the real world and respond to it in more appropriate ways. And another company I'd mentioned that's working on voice recognition and emotion recognition within voice. So I'm curious, as you layer that on top of some of these things we're talking about, what kind of additional insights we get and tools that become possible.
I think, so we do work in several of those areas. So one is sort of diagnostic. So we do work in our speech lab to see if we can detect things like depression, PTSD, and things like that from spoken interaction. And the initial results are actually quite promising in that regard. We've also looked at working with people who are visually impaired to help them get around the world. But you were talking about having disabled people of whatever situation be able to interact with the world better through computer mediation. I think that's a really important theme. The way, you know, the big headline that usually comes up is aging population, because certainly in Japan and in Europe and soon here in the United States, that's going to be an enormous issue. And that is, it's a real opportunity for computation to help through reminding, through, you know, visual cues, through warnings, through instrumentation so that you can make sure that people are appropriately active, all that kind of thing.
Great. Anyone else have thoughts on that? Emotion recognition? No? So I think we're actually going to move to audience Q&A at this point then. So if anyone has a question, just go ahead and raise your hand and someone will come around to you with a microphone. I think.
Soon.
Soon. Ah, there we go.
Hi, I guess it's on. Here, I'll stand. It's probably easier. Hi, my name is Mark Hockman with PC World. My son is 5. He's grown up with a tablet. He understands touch interfaces quite well. I don't really think he understands the point of a mouse. He doesn't use a keyboard at all either. I use a keyboard all the time. I use keyboard shortcuts. I use Windows 8, but I'm reluctant to take my hands off the keyboard. My question is this: at what point in the future do we get to the point where the keyboard becomes a legacy interface that possibly is phased out, just like a floppy drive or a DVD-ROM drive?
So I think it depends on the situation. So I'm not sure that'll ever happen, because there are some situations where keyboard is just the right thing. So again, a pen, okay, that's been, or something like a pen, if you go back to a stylus writing on clay, has been around for a really long time. That's because it works very well in certain situations. My own feeling is that keyboards will be like that. However, I think we will be seeing them a lot less, because your example notwithstanding, I think we use keyboards in a lot of situations where they don't belong because it's what we have. I think those will go away.
Next question.
So I'm a UX designer, and you know, right now I use a lot of the sort of things I know will be legacy not too far from the future. However, it's difficult to get the sort of the gesture. I'm starting to think about including gesture, including voice, including touch, and then 2D, 3D. There's a lot of things. I'm excited about it, but just from a practical point of view, I'm just thinking about how do you put these things together. I've seen white papers from Intel and so forth, but I'm interested in how you start to think about these things in concert with each other, in addition to the use cases, in addition to the actual purposes involved.
Well, so I think there are a couple of problems. Other people should speak to this too. But first of all, these things have to work really, really well for people to accept them. And some of the things that you just went through don't work really, really well yet in the real world. So I think we have a ways to go. But the other thing that actually Andy brought up a while back is the whole concept of metaphor. How do we think about these things? So right now we have a desktop metaphor for a lot of the computation that we do, even on tablets, by the way, which at one point might have remotely been connected to a desktop. I mean, it's gone pretty far from that. But it's a metaphor we understand. We know what the icons are. We know what it means to move them. We know about opening them and all that kind of thing. I think it's pretty unexplored territory as we go into some of the things you're talking about. So to me, the question for you UX guys is, what are the metaphors of the future? How are we going to think about this thing? Games have that, but beyond that, I haven't seen much.
Yeah, there's an interesting problem that we run into all the time, even when we're building our little lab prototypes, is what is your engagement model with the technology? If you think about a mouse, I mean, one of the brilliant sort of unsung features of the mouse is that when you take your hand away from it, nothing happens.
Yeah.
It's a really important property, and if you're standing in front of an Xbox with the Kinect device, you have to find a different way to do that. Speech is the same way. I mean, look at the struggles that they're having with Google Glass, finding something that's socially acceptable and works and is reliable. And part of that is because our engagement model is a binary thing, right? Because we're still stuck in these kinds of event-driven models where we need, you either know something or you don't, right? It's either on or off. So the kinds of programming models that we need in the future are probably going to be much more along the lines of a probabilistic network, or dealing with uncertainties and likelihoods and so forth. And so I think the challenge there is like how do you develop using those tools? What are the tools? They're very different than what you're using today. And right, so there's a huge body of work there just to do something about that problem.
Do you guys think, I'm going back to very old days, but in the 80s, Xerox actually had voice-controlled copiers. We stopped. It was not socially acceptable to talk to your copier. And now that it's socially acceptable to walk down the street and talk to yourself, have we overcome that barrier so that everyone can
I think so.
Not technologically, I mean, socially.
No. Overcome, I don't know, but there's certainly been some differences. So in days before Siri, we were going around talking to people roughly about the concept. And one of the very consistent critiques that we heard was that nobody would talk to their phone in the sense of talking to their phone as not using their phone. There was widespread belief that people simply would not do that. Okay? Cars, ditto, right? And now, not everybody does it, but we're seeing it more and more. So I think it's changing. I do, it's like the 5-year-old kid. I think it's a demographic thing. It'll be very natural to be talking like that. I think it'll change.
I was actually talking to one for a story a week or so ago with one of Google's main voice researchers, and they said that there are issues they deal with, but that's not one of them. That's not something they see in the sort of social concern. The bigger one is that it doesn't always work well, and so people don't come back to it.
There is that.
That's probably the number one thing. Next question.
I have one over here on the right side. Ooh, this is nasty sounding, sorry. Hey, I have a question I'd like to address to Andy, but I'm happy to hear from the other panelists as well. What is the television interface of the future?
Oh, man.
Okay, Andy, what's the television?
That is a tough one. It sort of begs the question, what is television in the future? And I really don't know. Yeah, it's... You're thinking like, are we going to do something with remote controls or something like that? Is it going to be speech driven? I mean, people are pretty excited about the speech interface on the Xbox. It actually kind of works. And it's, one of the advantages there is that, you know the audio because your device is the one that produced it. And so there's a lot of modeling of that and how that impacts the acoustics. Right? Some of the problems that we're talking about here when speech fails is, part of it's an acoustics modeling problem. And there they've solved it with the Xbox, more or less. And so it's surprisingly good. And so maybe that's one. I think one thing that I find a little bit interesting is that when you're gesturing in front of these things, doing these sort of very broad gestures, very sort of, telegraphing what you want to do to the system, I think what people really want to do is they want to do something very small. They don't want to do something like large. They want to do like little micro gestures, and partly because we're fundamentally we're lazy, and you don't want to exert a lot of effort to make something small happen. Or part of it is maybe it's a social acceptance thing too. You don't want to look like an idiot. But so one sort of interesting research challenge is how small of a gesture can I make and affect a change across the room. Now certainly I can even do that to you right now, right? You're all the way over there, and I can point with my head. I can say, look over there, and you'll probably get the right table at least. And so, so there is this sort of fidelity that we don't have right now. That'd be interesting to see, that we can look at these kinds of interfaces. That I think that's an exciting area.
I have to say, I'm not much of a TV watcher, but if I sit down at my TV, it says, "Hi, Walt," because out of all the family members that watch it, it recognizes me somehow, and I can talk to it or gesture to it. But every device that I have in that room wants to be the controlling device for my entertainment life. So the DVD player wants me to use it to control everything. The AV receiver wants to control. The TV wants to control. All of them want me to stop every 2 days and do a network-based software update or firmware update. And so I think so little about, we're still sometimes in the dark ages of, okay, I just spent $500 on this Logitech computer to control my things, and I still have to have five devices there to watch, The Daily Show.
I'll just throw in that another question is, how interactive is it going to be? And so this gets back to what is TV, right? So I think the technology is there to make it much more interactive if we want it to be. There's all kinds of questions because most TVs sit in living rooms, and it's back to my thing about multiple people being in the room and how does all that work. But personally, I think that's the more interesting dimension. How is a group of people going to interact with the TV, whether it's a bunch of sports fans or the family watching a family show? People still do that.
Yeah.
Right.
Next question.
Okay. So with the premise that people are becoming the new control mechanism in that of the digital layer of life, how do you manage multimodal interaction and things like selection? You talked about taking your hand off the mouse is a brilliant thing. Well, selection's a brilliant thing. There's a lot of interfaces. Now, if I had one click that I could do with my brain, think of motive, etc., and I could look at something and say, detail on that object, I could do a lot with that interface. So is anyone doing research on that kind of multimodal stuff, and how do you handle the real-world object selection problem?
Well, I mean, it boils down to that engagement problem I mentioned earlier. How do you're looking for a binary, like a digital signature, and you're fundamentally looking in the analog world. And so, maybe this is a great case where you're going to be using a keyboard and a mouse because what you're doing is fundamentally text editing, desktop publishing in the old sense. Right? It's maybe not the right not the right task for the fancy new multimodal interface, to book a reservation and a dinner. So, I'm not.
So is that the kind of selection you're talking about? I wasn't completely clear.
I was talking about, as we have basically intelligence embedded in all the devices around us, it's much more like grabbing someone's attention and trying to talk to them, right? In a room full of people, you can look at someone, direct your voice towards them, etc. And you now have that problem because you have so many digital devices in your life. And you can't hold a remote for all of them.
So I think, again, I do think it's an engagement problem because human beings have a way of doing that. So here, I'm attempting to look at you, even though you're sitting down. You can see me doing that. So human beings have a social way of understanding that. The point is, how are they going to do that in a computational world? And is the computational thing going to understand that that's what's going on? That I'm looking at this because I'm selecting it to talk to now. Okay. I think it's pretty unexplored territory.
We did a study several years ago where we gave people different ways to control lights. And we used a Wizard of Oz technique where nothing was really implemented. We just had a guy in the back who flipped lights on and off. And we found that the way that people really wanted to control lights, at least in our fancy living room setup, was to look at the light and then speak to it. And that was hands down the winner. And that's really hard. Doing eye tracking from across the room using today's technology is really quite difficult. I mean, it's one thing to perform eye tracking on a desktop computer, which is more or less solved problem. But to do it in a completely open environment such as this room or your own living room is still a very difficult challenge. But it's something that we can work on. I think it's not not impossible. So maybe that's one means of doing it. Certainly having a system that knows what objects are selectable in the first place goes a long way, right? So to build up the context of the objects that are available, what kind of lights are in the scene. If I want to look at the lights in this room, well, there are quite a few of them. It's going to be hard for you too. So
also,
the Clapper approach.
also, it gets back to the issue of context anticipation and the bright system and things like that. It's not just everything in the room that you could be possibly talking to or interacting with. It's of that, which subset are things that you're likely to want to be interacting with now, depending on what you've been doing, which hopefully is a much smaller set.
And we found the same thing in hospitals when a nurse walks into a room. There's not an unlimited number of things she's probably going to do. You can infer, if you understand the context, what should be put up on the screen the second she walks in the room. You might be wrong. She might have to back off. But depending on your model of the context, the history, and so on, you can really narrow down. If you walk in your bedroom at night, it's probably that light that you want to go on.
Yeah, it's remarkable how little precision is required in that task. And one of the if you're stumbling into your house at night and you've had a couple drinks, you can still manage to get the lights on. And I think looking back at it, we had a UX designer ask a question, I think that's an interesting point there, where today's interfaces require a level of precision which is greater than what is required to accomplish the task, right? We don't have a model that looks at what are the things on the screen that are available to select, and let's extract only the information at the level of precision that's appropriate to complete that task, right? You still have to get the mouse in the rectangle of the button, no matter if there's only 2 buttons on the screen, right? And that seems fundamentally wrong. We can solve that with various programming and development frameworks, I think, and it is a matter of research today. So these are interesting concepts, and I think these are solvable things, but they're not easy.
Next question, over here.
Yeah, so we heard earlier about the way interfaces or human-computer interfaces will be more personalized, be predictive, and therefore they have to get to know you. So how much of that do you think will cause us to have to give up our privacy and security?
So you have to give up information in order for the systems to be able to help you. Let me not say give up. Let me say share. Okay. The question then, and the reason I say that is because it depends on how you feel about it, who's looking at it, et cetera, et cetera. So one of my favorite stories that I heard from Mike Hawley, who's a professor at MIT, visiting his brother who was working in a small village in Cambodia. And he noticed after just a day or two there that anytime he went anywhere, there would be guys, usually 1 or 2 guys on motor scooters ready to give him a ride, no matter where he was. So at first he was horrified. My privacy is completely gone. Everybody in this place knows where I am, et cetera. But then he kind of got to like it because, hey, this is really convenient. So that's the way I think about this. So I'm delighted sometimes when I have shared information and the system does the right thing. If you think about your personal assistant, if you have one, or your friends, or your family, you want to share information with them so that they can anticipate your needs and do good things for you. The problem arises when you're in an environment, which unfortunately we hear more scary things about every day, where you don't know who all is seeing it and what they're doing with it. So that's where the problem lives, to me.
I think there's 2. I'm a little more on the skeptical side. I also think that in getting to the precision needed for accurate predictions and so on, that at least my life is filled with exception cases. And those are much harder to handle than the other 90%. And even with great models, it's a much harder problem than it appears. And you have to give up your privacy.
Hi, Daniela Vitas with IDC. I think this sort of builds on some of the last couple of questions, but we see in our research that on average, in the U.S., people have 5.5 intelligent connected devices in internet households. On a global basis, it's still impressive, between 2 and 3, depending on sort of the major region. And the number continues to steadily tick up, but I think with the compute devices coming and more mobile devices, we're not going to sort of, I think, go down in terms of number of sort of intelligent connected devices. So we've got these siloed experiences in many instances. And in order to have these great anticipatory experiences, it needs to somehow come together, right? So my phone knows more about me than probably any other device, but I don't just use one phone. I realize I'm probably an exception. Again, I'm in Silicon Valley. But you think about your work computer, your home, your next-gen television, and your game console, and your tablet, and so forth. We have different operating systems, et cetera. Do we all have to sort of eventually all get to the cloud and it's in one place, or there's some federation in order to really understand context appropriately? Or we're still going to have these better than today, but still not quite optimized because my car doesn't understand my experiences in context to my phone, to my home, to my work, et cetera. I'm just sort of curious about, does it have to really all go to the cloud? And not even just that, but really come to a single place, which I'm sure Google would love, in order for this to really, come to fruition?
I thought of that question.
I think there's 2 issues. There's one is directly related to the previous question about security and privacy and how you and everybody else feels about information going to various places and especially being centralized. That's very scary for a lot of people, including me. But I think actually even trumping that are the business model questions. So the main reason I think that information about you is balkanized is because there's different business interests vying for it. So Google wants to own this piece of the world. Whoever your phone provider wants to own that part of the world. Whoever provides the stuff in your living room wants to do that. And getting a business model in which those things are shared, I think we're far from, personally. So I don't think it's technical as much as it is business.
Yep. If you owned your own data and could do information arbitrage on your own self, it would be extremely disruptive to everyone else's business model out there. The other thing is you could inject a chip, RFID chip, and carry it with you, like they do with cows and so on. So.
I'm sure that feels good to everybody out there.
Everybody like that?
Next question over there, I think, in the back.
I have a question for Bill. You talked about something about sharing information. I want to understand in today's mindset, people's mindset, does sharing information still win over being anonymous, especially when you have something intelligent which makes life easier?
I missed the last part about anonymous.
Yeah, so do people in today's world, people's mindset, do still people prefer sharing information over being anonymous just because some device is going to intelligently help them live their life better?
I think it depends on who they are and what they're doing. So all of us who have kids, especially teenagers, are aghast at the amount of information that they're comfortable sharing. Anonymity doesn't seem to be very important in most circumstances. Other people feel differently. If you're doing something that you consider to be risky in the information space, you might want to be anonymous. There's a whole set of questions about whether you can be anonymous, and frankly, I doubt it. So people might want to be anonymous, but that's getting very difficult to do. So I don't have a really crisp answer. I think there's going to be a range of willingness to share, and I see willingness to share going up. I'm not personally approving or disapproving that. I just see it going up for most people.
Yeah, hi, Steve from Microsoft. I have a question actually for you, Walt. You threw out a term that I hadn't heard before called the transparent self. And I'm one of these, I don't know if I'd call myself quantified self, but I step on a Wi-Fi scale and not wearing it today, but I wear a Jawbone Up and I run with a GPS watch and get my heart rate monitor, and I start meticulously logging everything. It's almost...
Yeah, you're wondering if your quantified self, you are.
So could you say a bit more about this term, the transparent self, and kind of what you think that's going to mean in terms of how it might change our behavior?
Well, I guess the transparency that we've been talking about is not to others, it's to ourselves. And that where the opaqueness comes is there's this digital wall, and it's an economic-based divide that once it gets over to Google or, pick your vendor, it's gone. And you don't even know what's there, what they're doing with it. And it's, you don't know, by and large, did it come from my brake pedal or my iPhone? Who knows? And so we've been trying to look at what can we do to identify as many things as we can to make it transparent to you. And even the difference, I was telling people I got my first non-Apple phone in years, and now it's a Droid. And when I want to download an app, it makes me actually look at all of the things that it basically says, if you download this app, you're going to have to tell us this and this and this and this and this and this. And I feel queasy and go, okay. Whereas the iPhone, it was just, load it. And it comes back to the woman over here's issues as well. To the extent we can make it transparent, and it will never be perfect, it can help guide you to make better decisions on what I want to do and what I want to share. If I'm actually going to use that as some kind of functional entity that's going to interact with other parts of my life, you immediately get into the where's that located? Are there standards? How am I going to do that? But for us, the first issue is just people seem to have no visibility into what really exists about them out there. And I think the Prism example kind of knocked it home to a lot of people that didn't think it was as prevalent as it is.
Do you think there's certain consumer behaviors that might change if we had that amount of transparency?
Again, I think for some people it might. I think there's these cultural shifts going on where, my 11-year-old doesn't mind sitting and talking to the TV over and over and over. TV, no, TV. Trying to get its attention where it drives me crazy. Not just, so to the extent that they care, it's not as much, but they've never been burned yet. It's part of it is we get wisdom and we know it can go wrong. So I see, the things that are of interest to them. My high school daughter might not want Mitzi to know that she's doing this, but the things that matter to me in my life, I think it varies drastically according to age, demographics, and so on.
Next question.
Hi. My name is Ranajit. I'm from Intel. A quick question about, I know it's all about human-computer interactions, but to some extent, to know the context, some of the engagement factors that you said, where would the machine-to-machine interface has to be in, say, around 2020 to give us that we can all interact in a space, computational space? What do you think about that we have to achieve in this machine-to-machine space interactions? So that I walk in my room, that my phone talks to my TV, talks to my computer to know what context, what kind of engagement I need to have at that point in time. So where do you think it's going from that standpoint?
Well, again, so we, and my guess is my colleagues, have built systems that do that now. I mean, we were building systems that share that kind of information 10 years ago. I really do think that it's a business model issue. That's why it's not happening. It's not the machine-to-machine aspect of it. there are technical problems. I don't mean to be completely dismissive of it, but that's not the main thing. The main thing is what business model would make it a good thing to share that kind of information. And it does, ultimately, it gets back to consumer demand, or in Walt's world where I own my data, I think regulation is what's going to be
it would have
there.
But it's one, adoption of non-standard idiosyncratic systems and devices, pushing you to, at some point, somebody realizes there's a business model that we're going to have to work together.
Just one follow-up is, you mentioned that if it doesn't go to cloud, if it stays within my machines that I own, doesn't that make it a private data to some extent? How does it stop from doing that? What kind of regulation stops that
from having, what kind of regulation would stop the data on your devices?
Not going to the cloud and making it maybe available to Google per se.
Well, I think you're being optimistic about your data actually staying on your device. There's a lot of people who know how to get it off your device, frankly. So that's one problem. But when we talk about going into the cloud, that doesn't mean shared, right? That just means off the device. Sharing is a different problem. So I'll just go back and say it's going to be regulation and maybe a magic business model in the future, right? That's what's going to drive it.
Hello, I'm Satya from Salesforce. So based on what I heard today, we kind of touched upon visual, touch, and voice. Do you see it evolving towards other sensory inputs like smell and taste to complete the human experience?
Well, again, that to some extent exists now. There have been very serious research attempts to create sensors that exceed the human ability to smell. I mean, clearly, as everybody in the room knows, it's a matter of detecting certain molecules at a level of concentration. And that's what smell's all about. I haven't personally, maybe Andy or Walt does, I haven't seen that integrated into an interface experience in any non-joke kind of way. I've never seen that taken seriously, but my guess is it's coming.
So one thing, I was just going to say that we've done a little bit of work on imaging outside the visible spectrum. Yeah, and so there's a lot of stuff that we've seen in infrared, near infrared. We just completed a project the summer before this last, and using terahertz imaging. So this is a new series of devices and technologies out there that allow you to sense past the near infrared, and it allows you to actually look inside objects. Water is opaque to it, so you can't actually look into someone in the way that you would with X-rays. But it is a lot safer than X-rays, and we did a quick study on using that technology to look into 3D printed objects, and then to encode information inside a 3D object to, say, make it unique to all other objects that look like it on the surface. So having one-of-a-kind imprints on the object. So there are all sorts of interesting sensing technologies that are superhuman, and more and more things are coming out all the time that do this kind of stuff. And so that's definitely one of the things I've been trying to track. Sort of what part of the electromagnetic spectrum is the next thing, and how can we exploit that to novel means.
Let me put the human back into this. There's your nose is pretty good. Not as good as a dog's, but there is research that shows you can actually have people eating bland, tasteless, nutritious things and getting smells, scents put in their nasal sensors that make things taste pretty good and make you think you're eating, maybe it's a McDonald's cheeseburger instead of a tofu patty. But, and you know, that's human-computer interaction, human-something interaction, but it's, you know, potentially worthwhile exploration.
I'm glad we've come full circle back to superhuman skills here. Yeah. So I think with that, we're going to wrap it up. But thank you. I just want to say thanks for all the very intelligent questions, and let's say thanks to our speakers tonight.
Thank you.
Andy, Bill, Walt, I'd like to thank you again for sharing your perspective so freely with us. We really appreciate it very much. And James for guiding the conversation so well. We have a Churchill Club speaker t-shirt for you. Please wear it in good health. And a video recording of this program will be available on our YouTube channel shortly. You will probably within the next 48 hours. You will receive a survey from us tomorrow. If we have your email address, please take 60 seconds and respond to it. And you've been a wonderful audience. Thank you so much. We'll see you next time. Good night.